components you need for a headless operation. You need a memory stick. I call them memory sticks because I'm part of the Sony generation. You need something to host and hold your operating system. You need your actual board itself, which will be your computer, a basic power supply. It runs off USB-C, which is amazing. And then you've got a case which will house it with ventilation and cooling. So let's put that there. Now, it's something worth noting that it's worthwhile researching that when you buy a memory stick or an SD card, that you actually look at the symbols. The symbols are all coded, and they give you different kind of performance features. It gives you an idea of what this SD card is more suited for. Now, there's a very important thing to note that when it comes to running a home server or a home computer that you're just going to designate for as a server to run your photo albums and stuff like that from, it's important to note that I/O is quite important, input output. So when it comes to servers, read and write operations are critical, because when it comes to these SD cards, there is a community on the internet that detail the different problems people have had running SD cards, and where the SD cards basically become corrupted and they lose everything on card, and they have to basically re-image the Raspberry Pi operating system again. So that's all. So I'm going to be running a bit of an experiment to see how far I get. I'm hoping I've picked a really competent SD card to get me going with. So yes, research the SD cards that you're going to use for your Raspberry Pi. Now this is the 5th incarnation, the Raspberry Pi 5, the 5th incarnation. I decided to wait. There is a 4 available, but I wanted something with a bit more juice and power. I went for the 8GB RAM edition of the Raspberry Pi 5 single board computer, simply because I'm going to be running Docker on there, and if you've never heard of Docker, highly suggest you do a quick Google search. But essentially Docker is quite memory and resource intensive, so it's going to be interesting to see how far I get with it in terms of like balance and performance and power. Now, I've already opened this earlier because I was scoping out all the different components that came with it. But in essence, this is what we're talking about. It's got your high speed and regular speed USB ports. It's got an Ethernet port. That should be a gigabit Ethernet port, which is what I'll be using because I'll be attaching it to my home server rack. And then you've got mini HDMI ports. Then you've got your power supply USB-C port. That's actually power supply in. So it's not one of those duplex cables where a Thunderbolt cable. It's literally just, it feeds the power in. There's a tiny little port there for a battery. I'm going to be attaching a CMOS battery, so if you're into you're building your own computers, your own gaming rigs, I have a CMOS battery on the board, and what that does is that it runs the board and the operating system that keeps the memory and the basic settings, the culture, time information, date time. It basically stores that information, so basically if the board is ever turned off, or if you lose power supply and it's never turned back on again, the CMOS battery is used to retain the basic settings. Another common complaint amongst Raspberry Pi fans is there was never a power supply or a power button on the board. There's one there, so a lot of fans are really happy about that. The thing that I really care about is the PCI Express expansion port. There's going to be a new hat released from Raspberry Pi, which allows you to sit directly underneath something called M2 hat, which allows you to attach an NVMe solid state drive. So if you've got a PlayStation 5, you may have expanded the memory on it once by putting 1TB Western Digital drive on there. This is exactly the same concept. It just makes the Raspberry Pi ludicrously a lot more performant and faster. Now you can run it obviously off of that. Some people eventually just move over and then just put everything on there. I'm going to be experimenting. I really don't know which way I'm going to be shifting, but it's important to note that you can attach your SD card there and run the Raspberry Pi operating system on there once it's been imaged. It's also worth highlighting that you can expand it and put a proper solid state drive there too. And now over here you've got another bank of pins. The Raspberry Pi Foundation called these GPIO pins. In a very simplistic nutshell, this is what allows the Raspberry Pi 5 to have functionality expanded. So for example, there's a Raspberry Pi 4 feature where it allows you to have a UPS built underneath, so you can have a hat underneath with a big block of 4 batteries with some rechargeable batteries in there. And whenever the power supply dips, so if you get a power outage, then your UPS bank will kick in, it'll run your server, and it becomes basically uninterruptible. So that's what Raspberry Pi Foundation consider to be HAT's expandable functionality. That's the best way to put it. And it does this through these pins here. And if what happens is that your board starts to get stacked, you get functionality building on top. So that's something worth to keep an eye out for. And then this little corner over here, you've got the fan. That's the case fan that will look is what we provide for cooling. So I'm going to put this over here, and then we're going to talk about The power supply, I've got the 27 watt power supply because I'm not sure how much juice I actually need to be running on here, but I decided to go for the 27 watt power supply. It's quite a chunky thing, but it's a direct input. It should be a direct input DC in power supply. Yeah, that's something for another day to confirm. Anyways, yeah, so it's a USB-C power supply, powers up to 27 watts. So that should be more than enough to run these times. And these things are really cheap to run. They don't cost a lot to run in terms of wattage and basically your electricity bill. So you don't need to worry about that. And then now there's one thing to bear in mind, that you don't need to put this stuff in a case. You don't need to house it at all. I just want to because I want to protect it from the elements, dust and stuff like that. Because dust does kill computers. It's a big problem for running these things. Now, earlier on I talked about this concept called headless. Headless basically means that you're running things without an attached output device like a monitor and stuff like that, which is probably what I'm going to do as well. I don't want to have a permanent monitor attached to it because I want to be using a remote desktop, which will be another video to talk about. So this is the case. I love how it's got the nice little Raspberry Pi insignia there, engraving on there. It's got this little packet. It's got the rubber feet that go underneath on the bottom, the non-slip rubber feet, and then it's got a heatsink for the main Raspberry Pi chip itself. That's your CPU. It's your case fan, and then this detaches, comes apart, and there's your little case fan in, which needs to go on, and that's pretty much it. This is the simplicity of. This is essentially all you need to run a small home server. For me, that's kind of what Raspberry Pi 5 is. It's a server that allows you to run homebrew custom applications to automate whatever you are interested in automating at home. It could be your Ring doorbell, could be all sorts, could be your home camera software, whatever you want. So thank you for watching. Stay tuned. I am going to be producing an assembly video. I'm going to put this all together, get it up and running, get the Raspberry Pi operating system running on there, and then I'm going to do another video where I'll be attaching the CMOS battery, and then hopefully a follow-up video with the expanding the SSD. So thank you.